Thank you. Thank you so much, Stacy, for the introduction.
The floor is yours.
Yeah, thank you so much. Hey, everybody, I know it's pretty late for a few people and it's pretty early too. Thank you for joining, first of all. Myself, Gathin, I'm the developer relationship specialist here at Zero Gravity Labs. So, my today's session will be on introduction and developer onboarding into the Zero Gravity ecosystem. So, I'll give you an overview on what problem. I'll just go to the next slide. Yes. So I will be talking about the introduction to zero G ecosystem. What problem does zero G solves? And like a detailed explanation how of our zero gravity's architecture, the use cases for building with zero gravity, how as a developer you can get onboarded into our ecosystem, and a detailed explanation about our team, our roadmap, what is our vision, mission. So it'll be a pretty much good walkthrough about our product. So yeah, I'm excited to get started. Hope you're excited too. So yes, what is zero G? Zero gravity is the first infinitely scalable and decentralized data availability layer with a built-in general purpose storage layer. So what does this mean? I'll start with the word availability layer. The data availability layer means a blockchain in which we can store data which can be retrieved later. So that is data availability layer. And on zero G, we have a storage layer. On top of the storage layer, we have a data availability layer, providing a huge database for blockchain. I'll just get in detail in the coming slides. So the capabilities are it provides a massively scalable on-chain database for Web 2 or Web 3 data, ideally for various needs, including on-chain AI. See, for example, if it's on-chain AI, we definitely need to store all the model data somewhere as a database, or like for training all the data, we need to store the model somewhere. So, but the current existing blockchains cannot handle a huge volume of data, pretty much of like 500s to thousands of GBs, which a single model may comprise. So zero G solves it by providing a huge database solution, more fast, efficient, and scalable compared to any blockchains ever present in the whole market. So the specific details will I'll just tell it later on. The overall functionality is to ensure seamless verification that the data has been accurately stored. So as I told you, the data availability layer is to verify that it is to store data and is to verify that the data is being present in the blockchain. So what problem does it exactly solve? The data availability problem. This data availability layer, as I told you, but there is a problem with it. This refers to the challenge of ensuring that all necessary data is accessible and available for verification, even when it's not stored on the main blockchain. See, the layer one blockchain, such as Ethereum, will not store all the data because it is very because of the problems like scalability versus security trade-off. Because if we want the blockchain to be more scalable, we need to reduce its security concerns. The layer one blockchain, such as Ethereum, so we use roll-ups or like layer two blockchains such as Polygon, Celsius. So all those blockchain layer two blockchains, they bundle data into bundle multiple transaction into a single transaction, and they submit it to layer one. So by doing this, we are reducing the amount of data that is stored on layer one blockchain, and also we are reducing the cost of the overall transactions. The transaction cost comprising in layer 2 is far less compared to storing and interacting the transactions directly on layer 1. So this data availability problem that we are having is we are not able to store all the data continuously in the main blockchain. So for the off-chain verification too, this provides a big problem as light clients, off-chain verifiers. The current blockchain consensus, like to run a node, you need to store all the previous history of the blockchain from the origin to the current block. But light clients are like for the layer two off-chain verifiers, which will have only a certain amount of data and it doesn't need to store the whole past history of the blockchain. So these are the problems that are, this is the data availability problem, and these are the causes for it. So why we need to solve the data availability problem? For example, let us start with layer 2 networks. The executed transaction blocks need publishing for light client verification. As I told you, the light clients need to access some particular data. They may not store the complete data from the origin till the current block, but they might need to access a certain point of data which was previously stored in the blockchain. So when layer 2 networks are like congested with continuous number of data that is being stored, it becomes difficult for the light client to access the data. The data might not be available, so there might be an error in the data, so the data might be missing. To solve all this problem, we provide a separate data availability layer. So that is the solution that we are trying to provide here. So decentralized AI, verification of training or interface tasks in decentralized network is crucial. So suppose while training, I am training my model and I'm publishing it in a layer 2 network. So when the client uses this model, but he needs to verify that the model was trained properly. So it needs to go back for a certain period of time to verify it in the blockchain. For that, we need to make sure that the data is available for verification, that the training data. So for that, we need a data availability solution to solve the problem. The next importance why we need a data availability layer is for the incentive mechanisms. Verification of historical tasks for rewards requires balancing cost and effectiveness. So we need to verify historical tasks, like what the main thing is, like you need to get access of previous like old data from the blockchain which was stored long ago, to verify it and provide incentivization to the node validators or like miners for the different consensus protocols, for different consensus for the different protocols. So this is why we are telling that it's important to solve the data availability problem. So let's just compare an example like how this data availability problem is solved by other chains which are similar to 0G. And in the future slides, I will tell you how 0G is more efficient compared to all the products available in the market. Celestia's approach. Celestia has a separation. Data availability layer is separated from the transaction execution. So as I told you, the transaction execution takes place separately and all the data are stored in a separate data availability layer, so that whenever we need some data that is need to be verified for a transaction, we can fetch it from the data availability layer rather than congesting both the data availability layer and the transactions together in a single chain. Consensus ledger validates data availability. Broadcasting data blocks broadcast for multi-sign certifications. So the data blocks are broadcasting for the multi-sign certifications, which will cause certain problems like congestion, speed, efficiency. So all these problems can be experienced during by this approach. The limitations that for the Celestia network was the scalability. As I told you, limited by broadcasting requirements. Next is the data throughput, capped at 10 Mbps. Mbps. So this speed is pretty much very less compared to what 0G offers, and it's not scalable. Suppose we have multiple clients accessing the blockchain to retrieve data from multiple AI models at the same time. We need to have a faster transaction feed and efficient data flow. For example, when you use a chatbot that is more prominent in the market, the transaction execution speed is very high and the throughput is very high. So to provide that in the blockchain, we need to make sure that the transaction execute in a very high phase. Next is the bandwidth consumption, increased by massive data sampling. As I told you, if multiple clients interact with the blockchain at the same time, this may lead to bottlenecks of the blockchain. That is, the data is jammed at a particular point because there is no other node that can take up these tasks and work on it and make sure that the data is stored on the data availability layer, or it can generate the proof for the stored data. Block times slow due to the bandwidth and broadcasting. As I told you, the block time is also very slow because of the bandwidthing and the broadcasting requirements. Next, we look into how eigen data availability layers solve this problem. They have a unique approach compared to Celestia, that is horizontal scalability. So whenever they think that they need more data that is required, like there are more interactions to the blockchain, and we need to increase or scale the blockchain so that multiple nodes are present, so that they can split up the tasks and they can verify it. For that, horizontal scalability is used. That is done by the scaling is done by adding more nodes to the blockchain. Next is quorum-based system. Uses a subset of nodes to verify data availability. Even though all nodes are present, a few nodes here in eigen layer are selected randomly as a quorum, and they process a certain data and make sure that the proof is verified. Security assumption relies on the majority of nodes being honest. So here the security is assumed that the most of the nodes are being honest. So that is the assumption and the approach that eigenlayer has. The limitations here: risk of unexpected asset loss. Nodes face the risk of losing staked assets due to slashing, which discourage participation. Here, if the node makes some particular certain mistakes, here in eigenlayer, they just slash the node from participating it further. That is preventing it from participating, making them lose all their staked tokens. Arbitrary quorum construction leads to potential security risks and bottlenecks. As I told you, the quorum that is constructed, that is a subset of nodes that is used for verifying the data availability. Is completely random, and it may have some potential security threats. As I told you, in 0G, we use a certain thing called as verifiable random function to solve this and make sure that the randomly selected quorum is on-chain provable that it's randomly selected. Next is data index challenges. Difficulty in maintaining reliable data retrieval without a decentralized storage system. As I told you, a 0G has a storage layer above which the data availability layer is present, but that is not in the case of eigenlayer. They don't have a proper storage layer under them, so which has problem in data indexing. If there is a problem in data indexing, a future retrieval of data might be very difficult with that. So yes, we'll get in the most interesting part of this session, that is how 0G solves this problem. So I'll just explain you two different types of blockchain. One is monolithic blockchain, the other one is AI modular blockchain. Monolithic blockchain contains all the layers comprised together, and it focuses more on decentralization and security compared to scalability. So its prime focuses on security and make sure that the data is decentralized. This is how initially the blockchain started. So they have all the execution, consensus layer, data availability, settlement, everything together in the same module. I'll not say it as a module, but as in the blockchain, over which the networking hardware is present. But in AI modular blockchain, we have different modules which perform different certain tasks, so that we could scale in whichever angle we want. This will provide us the opportunity and the option to scale the requirements. I'll just explain you how it is. So we have a GPU and networking hardware. In the future slides, I will explain you why our GPU is used here. The GPU is used to make it more efficient, and also it helps us in erasure coding. So the next is the settlement layer, where all the data gets settled. The above which we have the data storage layer. As I told you, we have a data storage channel and the data publishing channel. Data publishing channel will have all the data availability proofs that are stored. Data storage will have the actual data in forms of chunks, which is present all over the storage layer. Above which we have introduced a new thing which is implemented now, is the serving framework, which is a framework on which AI models and AI service providers can use our data storage to store all the models and provide service to the clients, similar to what is happening in Web 2, that is providing on-chain AI. So we are bringing the AI which is present in Web 2, like having a user comes and goes to a service, he interacts with the model, he gives in the input, the model provides output, the service gives us back the output. This whole thing we are making it into on-chain because of the storage layer available in the 0G, and because of the fastness and swiftness that we provide. So all these things have a common consensus network. So the consensus can manage this, and we could expand the consensus, the number of nodes, as the requirements for the data storage and data publishing increases. On top of this, we have the execution layer. So 0G DA is fully horizontally scalable for AI workloads. So this is how the whole overall architecture works. The client DA blob on the left side is the client. He sends in the data availability layer blob, that is the data that is need to be stored. The dispersed servers are present, which will do the erasure coding, that will split into chunks, where you can see on the slide as C0, C1, and C2. Erasure coding is nothing but splitting the data into various chunks. The disperse servers will disperse these chunks into all the storage nodes. The chunks are not present in a consecutive order. It is dispersed all across the storage nodes. Next, the data available, the storage node is present. See, for example, the top one has the C2 chunk, the next node has the C1 chunk, and the bottom node has the C0 chunk. So the chunks need not be in the same place. All it needs is that the chunks are present in different, it can be present in different nodes. What the consensus validator does is it will provide the validators provide a challenge based on our consensus network. Here in 0G we use proof of random access, PORA, in which we will provide a challenge to the nodes to provide a proof that the data is existing in the node. So by doing this, the validators can obtain the proofs from the storage network, and once the proof is available in the consensus validator, the proof is stored on the smart contract that is present in the data availability layer, which is present on top of the storage node. So the storage node is present. It has all the data chunks. On top of this, we have the data availability layer. The proofs that are present in the storage node are submitted into the data availability layers smart contract. And this smart contract stores all the proofs. And the validators verify whether the proof is right or wrong by using the proof of random access. This is the overall architecture of 0G. And if required in the future, we didn't implement this yet, but we will be implementing it once the mainnet is launched. So we can also, if needed, we can submit the ZK proof of all the proofs that are present in the data availability layer into the L1 chain. So this is the overall architecture. So we can go to the next slide. Introducing the first programmable data availability layer. As you can understand by what data availability layer is, what is programmable data availability layer? In the left side, you could see that there is an L1 or an L2 chain, and the blue color line that you can see on the third block is the smart contract. Suppose if the smart contract emits an event, that is, it needs to save some state or it needs to save some data, we can make sure that the contract emits a save state event. And what 0G will do is it will continuously monitor for a save state event. And if it finds that the contract that is present on the L1 or L2, it emits a save state event, it will initiate a 0G transaction, and the 0G chain will store the data in it. It will store the data in it, and it will manage the data, and overall will provide the security for the data. The other half of the programmable data availability layer is for loading the data. Similarly, if the contract needs to load the data that is present in the 0G chain, it will emit an event for load, that is to load state, and using the fetch callback function, it will be able to retrieve the data from 0G chain. The 0G chain will continuously monitor for the save state event to store the data, and it will also continuously monitor for the load state event to load the data back into the required contract by using the fetch callback function called by the contract. Introducing the first infinitely scalable data availability layer. As I told you, our data availability layer is infinitely scalable. In the left side, as in the previous slide, the client produces data blobs. It is divided into chunks, C0, C1, and C2. It is dispersed by the dispersed servers. It goes to the storage network. It is stored in different storage network. It will generate proof of its presence, and it will provide to the consensus network. So this part is pretty clear with the overall flow. What is infinitely scalable data availability layer? And by increasing the number of consensus networks nodes, we will be able to scale and avoid bottlenecks of like multiple transactions when it needs to be processed in the same time. Like as I told you in the previous AI example, when multiple clients try to interact at the same time and try to use multiple models to provide input or output data, so that time there will be a bottleneck when there is less number of nodes to process the data. So that's how we increase the number of consensus network which will be secured via restaking by eigenlayer Babylon. So what does eigenlayer does in an overall structure is they provide security when we stake ETH. They provide security to the applications that we deployed on Ethereum on the layer one. So by increasing the number of consensus node, we will be able to increase the overall speed. For example, if one consensus node is able to process 10 Mbps of data, if we have 5,000 such node, it's a whopping 50 Gbps of data which can be processed, which is like insanely huge, and no blockchain was ever able to achieve this. It was all possible because of by improving the consensus network, by adding the nodes to it. Introducing the first permanent data availability layer. We saw about how we can program data, how we can store data, how we can retrieve the stored data from the zero-G chain. Next, we saw that how we can infinitely scale our blockchain, providing a faster throughput, also making it scalable. Now we will see how it is permanent. That is how you can store data permanently on the blockchain. For the left side, you can see that the Ethereum blob data are deleted after 18 days. What is blob data? As per the EIP Ethereum improvement proposal 4844, based on this proto-dank sharding in Ethereum, what it does is like it reduces the cost for storing data for the L2 by providing blobs for the transactions rather than storing the data directly, the transaction data on the call data. So usually the transaction use call data to store all the data, but it will make it more inefficient and the price is really too high. So to reduce all this, and for the layer 2, we will have we are implementing the blob data concept. Blob data it is not read by the EVM. It just gets attached to the blocks and it will be used to read data, and it will expire in 18 days. That is what the blob concept is about. So what we do in zero-G chain is, if you need to store the blob data permanently for a certain period of time, you can index it in our chain, providing a certain fee for it. If you no need to pay an upfront fee. The fee is like how long you're storing the data, that long you can pay the fee for. Like no other chain is able to provide this, as they all have a certain timeout period in which the blob data is automatically deleted. So we solve that by providing a permanent solution, as you could pay a certain fee and you could store your data on our chain permanently until you want it. So this is what the permanent data availability layer means. As I told you, we are the most fastest, most secure, and most programmable data availability layer. We have the highest performance, which could not even be compared to what Celestia Eigenlayer Avail provides. On the security aspect, we are able to provide a wholesome security. That is, we will implement Ethereum security. Plus, on the data availability layer, we are having VRF, verifiable random function, to randomize the quorum selection, making it more secure compared to the other blockchains. So yes, the programmability, the storage, location, and replication is not possible, as the data chunks are spread over the network. The data is persistent, and also you could store the data as long as you want. Smart contract state management, you could load this, as I told you can save state into our blockchain, and you could load it from a zero-G, which is not available in any other data availability layer. Also, I'm happy to introduce the first generalizable AI serving framework. As I told you previously, the OPML, ZKML, and TEEML are used for interacting with the models that is present on chain. So I'll start with the number one, that is the client request. When clients request the blockchain for the models that are present on chain for some output, the clients provide request that is in the form of input to the blockchain. The blockchain will contain, the zero-G blockchain will contain multiple service providers who will store all the model data in zero-G and use us as a decentralized on-chain model storage. So the client requests all the service providers present on zero-G chain. the service providers interact with the decentralized storage to fetch all the data, process all the model data, and provide output back to the user. Here the interesting concept that we have is we no need to pay for each transaction. You need to just sign all the transaction, but the rest of the amount you could just have as a token in our blockchain. You will have an initial upfront deposit in our blockchain, which can be used for all the payment and settlement for all the transactions that you make. You just need to sign data, and relevant amount of token amount will automatically be detected from the deposit that you made previously. So by this, we can load multiple models, heavy models on the blockchain. We can make on-chain AI as efficient as how it is now in Web 2. You can make it fast. As I told you, ours is scalable. Ours is pretty fast. That is 50 Gbps of data. So you can just have it like how it is present in Web 2. You can have the same speed and scalability here in 0G. So as I told you, it is the fastest, and I should mention that it is the lowest of cost compared to any other service provider, including Web2 database storage, AWS. We are 80% lower cost than an AWS storage. So as you can see, the performance of 5,000 node is like 50,000 times faster than Ethereum Danksharding. And you could see other blockchains like Solana Firedancer, Solana Eigen data availability layer, which can maximum produce like 10 Mbps, 125 Mbps, and Solana Firedancer is like comparatively better compared to the other blockchains, providing 1.2 Gbps of data speed. But us, we are able to provide 50 Gbps of transaction processing speed. The cost per GB is extremely high in other blockchains, but 0G we have very minimal transaction fees. As I told you, we have our own data storage layer, so we don't need to store all the data in the data availability layer. We have a separate data storage. The 0G storage design. The 0G storage design is separated into three layers: the log system, the key value store, and the transaction processing layer. The log system is like continuous append only data, which will append the data rather than manipulate it. Like from the initial start of the 0G chain, the logs will continuously get updated so that we'll have a proper transaction of execution. And each time we need to store something, the log system will note the storage, note the log of the stored data. So next is the key value store. It enables the mutability of data with access control and allows applications like decentralized social network. By providing key and value pair, you could restrict like who can access the data and who cannot access the data. So all this is available in the KV store of a blockchain node. You could run this blockchain node on your own system, which I will be explaining it in the developer onboarding part. Next is the transaction processing. We also have the asset properties for applications with concurrent update. For example, we can say that the Google Doc with collaborative editing. You could you could do all the functionalities present in a normal database storage in Web 2. You could do everything here in Web 3 on 0G chain. As I told you, the 0G storage can be used for generative AI, Gen AI generation. So 0G is solving all the problems and like faster retrieval, faster SSD lane, the storage type log, KV, and transactional. So we are able to separate different data. If it's just append only, we can append. If it needs a key value storage, we can use KV store. It is low cost for the storing and also for the retrievaling of data. So similarly, we have storage location replication, which I explained in the previous slide, the smart contract state management, the save state and the load state. And also we also have a wallet compatibility. That is, all the EVM compatible wallet will be able to use 0G chain network. Next, I will be explaining on a few use cases that you could use 0G for. AI and data intense applications. So you can store vast data sets. You can run AI models fully on chain, 1,000 times performance over Ethereum, 4 times over the Solana's Firedancer, 1,000 times performance over the Ethereum's dank sharding. Next is for the layer 1 and layer 2 networks. You can use our network completely for the data availability and storage. That is, you will have all the storing, all the data that it needs to be stored. You could use our chain for it. We have multiple partners like Polygon, Arbitrum, Fuel, and Manta Network who use 0G for their data storage and data availability layer, which will have all the proofs of the data storage. Next is you could build bridges on 0G and make it cross compatible for all the layer ones, secure cross chain transfers, store and communicate user balance. Since we provide a good data availability layer with faster transactions with the good security, you can use 0G chain to build bridges to bridge all the tokens between different layer ones. Next is for the on-chain gaming, large-scale on-chain data storage, reliable storage, cryptographic proof-related data, player assets, actions, and metadata. Here, the highest, very interesting possibility here is the on-chain gaming. We will be able to enable on-chain gaming as gaming needs to store a vast number of data that was not possible till now. Like everyone used off-chain data storage for gaming applications, but now you can store all the data, the players, the tokens. If it is a P2P game, you could store all the metadata here on chain. So that is why on-chain gaming is a very good use case for 0G. Next is decentralized finance. We support high frequency trading and efficient DeFi on specific L2s and L3s due to fast settlement and storage. Because of our faster transactions, we can make it to real approximately to the real time, so that you could make the DeFi, all the DeFi applications, the markets, you could bring it on chain using 0G because of its faster execution and also the storage availability and the faster settlement rate. Rollups as a service, data availability options and storage for RAS providers like Caldera and Altlayer. We can provide options and storage similar to how we provide for layer 1 and layer 2 for all the rollups, which uses our RAAS, rollups as a service. Next, I'll walk you through the developer onboarding. Stacy, could you please switch over to the screen share? Thank you so much. Yes, this is our website. Here, we just gave an overall introduction. We will be updating our website constantly. We are pretty early in the market. So we have listed out our partners. We have our team here. And you could subscribe to our newsletters to keep to be updated on like what is happening in our ecosystem. The next thing I would like to introduce to is to our blogs page. You can have all the really recent updates that are happening over all the partnerships, all the technical updates that are happening. Recently, we launched our testnet version 2 here. Soon, we will be launching our node sale and mainnet. So just have a look at this blog section and subscribe to our newsletter so that you will be updated on what is happening in our ecosystem. Next, regarding our documentation, so we have a separate documentation for developers to understand the data availability layer, the storage layer. Here they could understand all the repository structure, like how we completely developed it. They can open source contribute to it and improve it and be part of the 0G ecosystem by contributing it. So other than you could have all the details for the data availability layer here, all the details of the storage here. The next is the SDK that we have. We have SDK for interaction with the 0G storage for uploading data, downloading of the data. Currently, we have two SDKs that you could use for developing in the hackathon 2. That is for the TypeScript one, and the next one is a Go language. So you could use either one for interacting with our blockchain by using this SDK as our client. The next is we have a dedicated YouTube channel in which we will constantly be uploading tutorials, hands-on sessions, ask me anything, a few examples, code run through, code review. We will be doing multiple things. We will be uploading all the speaker sessions that is happening in multiple events that we participate. So all those details will be uploaded in our channel. So we also have a lineup of good full stack examples that is to be uploaded. So you could use our channel for reference for tutorial guides. So before I proceed further, for running a node, we have a separate documentation with all the configuration details, and you could run your own validator node with a simple one-page documentation, which is like very easy, and someone new to Web3 also could understand this. We are also improving from our side, getting feedbacks from the previous hackathon participants and other Zero G ecosystem community members. So we are listening to them actively, and we are updating our documentation too. So we have the documentation for running a storage node and data availability service. We have the CLI commands to run the storage node, and we also have a dedicated contribution guidelines, which we will be expanding it soon. And we will have a detailed way on like how you could contribute effectively. The next is our Twitter channel. We have the Zero G Labs. We have a whopping 300,000 followers, and yeah, you could just follow our channel and like stay updated. We will post all our updates, all the upcoming programs that you might be interested in. I'll be sharing it now after a few slides. So Zero G Labs, just follow our Twitter to be updated on what is happening in our ecosystem. The next is our Discord channel. Our Discord is having a whopping 200,000 members. Uh, Here we have dedicated channels for hackathons. We have content submissions. So content submission channel where like community members actively contribute to our Zero G ecosystem, whom we are extremely thankful for. We also conduct multiple competitions. So just keep the notifications on and like stay tuned. We also have our community members showing their creativity by providing multiple memes on our ecosystem. So yeah, we encourage all sort of contributions to our ecosystem, whether it may be technical by running a node, being a validator in our thing, like contributing to the overall development of Zero G ecosystem. We pretty much welcome in all aspects. So this is the overall thing. Stacy, could you please switch back to the slides? Thank you. Yes, this is a brief update of what has happened in the past. We have attended 5 major Web3 conferences and events: ETH Denver, Hong Kong Web3 Summit, OKX School Tour, Token 2049 Dubai, Game 3 Riyash, Consensus Austin, Super AI Singapore, and a few more. We have so far conducted 21 panels, 18 keynote speeches, 4 media interviews, 3 Discord Ask Me Anythings. We on average, which we have 6.6k views on average in the sessions, and we also conducted 9 Twitter Spaces, which is both like Ask Me Anythings and also regarding the updates that is happening in Zero G. In the past, which happened around like 2 weeks ago, we conducted a hackathon in collaboration with One Piece Lab, and DAGI will be the second hackathon that we'll be conducting. And stay tuned for more hackathons that is to be conducted soon. And we will be launching our mainnet in the next month, so we will be pretty actively participating in hackathons after that. So here is a brief sneak peek of the upcoming programs that we are initiating it. That is the ambassador program. You could be part of Zero G. You can represent Zero G in multiple events. You can provide content. You can provide local. You can conduct local events in your place about Zero G. So that is regarding the ambassador program. The incubation program, which we already onboarded 1 cohort. So this and we will be soon onboarding the next set of projects. So just subscribe to our newsletters and turn on the notifications to be updated on what is happening in the ecosystem. So the incubation program will be incubating projects to projects, the early stage products, idea stage, or it's in a pretty good level, who wants to integrate Zero G into their product. So we incubate such products, we provide proper mentorship and guidance, and we make sure that they go out with a proper integration of Zero G, and they are able to shine on like what they are able to learn from us. The next is the developer launchpad, which we will be launching it soon in the next month, where you will be able to contribute. You will be able to do open source contribution to the program. In return, we will be sponsoring you for the hackathons, conferences in which Zero G attends. So that will be definitely exciting. So stay tuned for it. And as I mentioned, the hackathons, we will be participating more in the upcoming days. Also, we will have an exclusive Discord role for all the participants in the hackathon who make their submission on zero G. So we have the title called as Zero G Wizards. This title will be provided on our Discord channel. The role will be provided to the participants who make their submission on hackathons. And in future, we will definitely have like multiple benefits for participating in zero G. You will be prioritized in few things. So all those updates will be you could hear soon in our Twitter and on our blogs. So yeah, as I told you, there are a lot of ways in which you could be in part of zero G. We also have a career section, so you could, if you are interested in applying for a job role, just go there, just ping in or fill the form details. We will definitely get back to you. So regarding the team and our roadmap, so I'll just start with the mission, vision, and values. As I told you, our main mission is to make AI a public good. That is, the AI must be accessible by anyone and everyone on chain, not off chain. So that is what we are bringing here clearly. The vision is fully on chain AI. To support our mission, we have the vision that we need the fully on-chain AI. So the values what zero G represent is zero G mission comes first, E empowered family, R real speed and adaptability, for O openness and ownership, G is for growth mindset and accuracy. So more than focusing on the product, we are more focused on the community, bringing the product to the community along with the communities, and like hearing it from you people, like how we should take the product further. So we have a certain mission, vision, and like we have a roadmap for it. But definitely we have the community involvement, and the community is what we prioritize in getting our product out to the market. So your involvement is what will boost that will only encourage us to provide the best to the market. So here is a very interesting slide of this presentation. Is my personal favorite is the slide on our founders and the executive team. You could literally find all the top institutions and like the top graduation schools here, and our founders have been completed PhDs, and like they have graduated, they have completed a post graduation in Stanford, Harvard, Massachusetts. And Michael, our founder, has generated in the previous startup he launched, he generated 200 million revenue, along with raising a capital of 200 million. So he has led a team with 650 people. We have 5 gold medalists in the informatics Olympiads, top academicians with 8 computer science PhDs. So we also have the best cryptographers present in our founding team. So pretty much this was the reason why I joined Zero G, because the products can be iterated further. The products, we can change it further. The idea may evolve. We can have our community suggest a few updates which was not planned early. But everything can be handled if there is a strong founding team. And I'm proudly happy that we have such team with us. So yeah, and Ada is our CMO, Visa is the chief of staff, Jason is the VP of AI, Dong is the VP of blockchain, and Tiffany will head the VP of ecosystem. This is our core team who will be taking care of the overall zero G. So the other interesting slide is we have raised 35 million pre-seed, $35 million from tier 1 investors. And the round was led by Hack VC, and we were 20 times over subscribed. So this is the highest pre-seed in the amount raised. 35 million is the highest pre-seed in the blockchain history. So we are pretty excited to provide the best of the research quality in our products. So we have multiple partners across the industry for the demand side, the AI models, execution, as I told you, the service providers. We have Aura, for example, L1, L2 applications who use zero G, Polygon, Optimism, Arbitrum, Manta Network, the infrastructures providers for all the node related things. On the supply side, we have for the ZK part, restaking GPU and oracles. Also, we have a very good number of partners. And for gaming, we have Gaimin and the other partners. So we pretty much have a good set of initial partners, and we are expanding it further as we scale in our zero as we scale our product to. So this is a draft roadmap that we have. So I could just tell that in the next month we will be having our token sale and also our mainnet release. And after that we will be having multiple hackathons. We will be conducting multiple programs. As I told you, ambassador program, developer launchpad. So it's pretty much going to be interesting as we are about to complete the testing phase and we are launching it mainnet. So yes, you could scan this QR code. You will be able to see all the links that I showed you previously. It will redirect to the link tree, which contains all the links for the social handles and also to our website, YouTube channel, blog page. And if you want to connect with me personally, as I told you, I'm the developer relations specialist here in Zero G. So I will be handling all the developer onboarding part, hackathons, like what is required from the community. I will be the bridge between the team and the community developers. So you can connect with me on Twitter at Gathin_TWT. So that is my handle. Feel free to ping me anytime. I'm happy to reply. I'm open for more collaborations. We are actively looking for more collaborations, involvement from the community. So yes, together let's make AI a public good. A very big thank you for everybody, and also to the DAGI house. I'm representing the Zero G team to thank you wholeheartedly. So, and also I will not be able to attend in person in the hackathon, DAGA hackathon, but I'll have my team present over there, and I will be available for technical support online. So looking forward to meet you all and also to see you in person in the upcoming hackathons. Thank you so much.